Okay, today we're starting a new unit. We've done a whole lot about lines, angles, and triangles. We're going to start learning about quadrilaterals for a little while now. So since we've got a new unit, you're going to go ahead and label pages 72 and 73, Unit 3, and we're going to glue in your new tab, which is attached to this video, or will be given to you in class, of course, if you're in class. So you're going to cut off the extra space. You're going to glue this so it sticks out on page 73. The first one we're going to do is 9.1 Properties of Parallelograms. That's what this video is. We will finish Module 9 between now and Christmas break, and then we'll pick back up with Module 10 afterwards. Okay, there we go. So we are doing 9.1 Properties of Parallelograms today, so that's 74 and 75. So go ahead and turn to 74 and 75 and label it 9.1 Properties of Parallelograms. Get something to write on. Okay, so 9.1 Properties of Parallelograms. A parallelogram, which I'm about to define, is a special type of quadrilateral. And of course, a quadrilateral is anything that has 4 sides. There are specific types of quadrilaterals that we'll talk about more as we continue. For instance, a rectangle is a parallelogram, and we'll talk about that. So for a little while, you are going to need your textbook in a few minutes to cut out some pages, but for now, we are going to write in our notebook about parallelograms. So let me zoom in. Page 74 here. Start with the definition of a parallelogram. Okay, a parallelogram is a quadrilateral, remember 4-sided shape, with 2 opposite sides parallel. And I'm going to draw one. Grab a straight edge. We'll draw a parallelogram. Okay. Something that I know, by the way, is that a ruler is parallel already. So when I draw this, I know it's a parallelogram. And I'm just going to connect. The lines on your paper is also parallel, so it's a parallelogram. You will often see the marks to show it is a parallelogram, and those marks look like this. If you remember, parallel is an arrow. So these are parallel, and so are these. That is the marks that you will see for a parallelogram, okay? So let's talk about the things, the properties that are true of parallelograms, okay? There are a number of items that are true given a parallelogram. We're going to list them. And I'm going to color coordinate them. I almost always spell parallelogram and quadrilateral wrong, by the way. Don't know why, but I do. Okay. By the way, anytime you're using something, if you talk about opposite sides parallel, that's the definition of a parallelogram in a proof. Any of these 3 that I list are a property of a parallelogram in your proof. So make sure you know the difference. There is a difference. We will talk about the difference. Okay, here's the first thing that's true. The opposite sides are congruent. We are going to prove some of these. There are 3 of them. The opposite sides are congruent. Also, the opposite angles are congruent. And the diagonals bisect each other. And we'll talk about what a diagonal is, in case you do not know. Okay? So we're going to draw a parallelogram and label all of these pieces in their color-coordinated fashion there. So if we are given that EFGH is a parallelogram, then we know these 3 things. We're going to label them, but first let's draw EFGH. So I'm just going to draw a parallelogram just like I did right here. To make this one 3 boxes long, so I've got enough room here. E, F, G, H. It is a parallelogram. Okay. The first thing we know is that the opposite sides are congruent. So EF is congruent to HG or GH. It is GH. And EH is congruent to GF. And the reason it's EHGF is because of the angle piece that we're going to talk about in a minute. So EHGF. Okay, that's the first thing we know. The sides are congruent. Now the angles. E is congruent to G. And F is congruent to H. Last, the diagonals bisect each other. I can pick up my straight edge. Here's a diagonal. A diagonal goes from the opposite side, opposite angles, or opposite vertices. There are 2 diagonals in any quadrilateral. So this means that they bisect or they cut each other in half. We'll draw that. So HF, you put and, not B there. I was about to say bisects. And EG bisect each other. Meaning this piece and this piece are congruent, and this piece and this piece are congruent. This is everything we know if we are given that something is a parallelogram. Each of these, if I use them in the proof, is a property. This is the definition, okay? We might need to, let's go ahead and just distinguish that up here. Properties, definition. So distinguish that so you know what the reasoning is behind your proof, because we're going to do some proofs. All right, we are going to do proofs. You need to pull page 421 out of your book. We're going to cut it out. We're going to do a proof to prove one of these 3 properties. We're going to prove that the angles are congruent. So you're cutting out example 2 on page 421, the box underneath it, and gluing it in right here. So this is all you're cutting out from 421 is this. Let's slide this on up a little bit. There we go. So glue that in. The bottom is 74. You don't have room. You actually will have room if you need to glue down 75. That's fine today. Normally it's not okay, but it is okay today. It's fine. We're not putting anything else on 74 anyway. All right, example 2. Prove that the opposite angles of a parallelogram are congruent. Now, we can't use, well, they're congruent because it's a property. We're proving that that property is actually true, okay? However, we can use one of the others. So we could use opposite sides are congruent or the diagonals bisect each other. That's fine. Okay, example 2. ABCD is a parallelogram. Well, that's our given. Next, it says draw DB. You're not used to that step. For years, that's already been filled out in this proof, so I'm actually surprised. The book has changed. Okay. So it says draw DB. To say that, what we're going to say is any through any 2 points. There's exactly 1 line. You always say that if you add a line yourself. That's all you ever have to put. Okay. All right, next. AB is parallel to DC, and AD is parallel to BC. Well, that's the definition of a parallelogram, because the definition says opposite sides are parallel. Okay? What we are trying to prove is that the opposite angles are congruent. For instance, AC is congruent. We don't know that yet. However, normally to prove things in a figure, you almost always are going to construct a triangle, which is why we drew DB, and then prove that the triangles are congruent. And proving that the triangles are congruent will help us show that the corresponding parts are congruent, okay? So that's actually what we're going to be doing. So they talk about alternate interior angles theorem. So, and then we've got angle side angle triangle congruent theorem and a reflexive property theorem. So here's what we've got going on. We actually are going to try to prove that ADB is congruent to CBD. So in order to prove that, we need to talk about some angles, okay? ADB is congruent, ADB, to CBD because they're alternate interior angles. So we're going to write that. Angle ADB is congruent, ADB, to CBD because they're alternate interior. They did not give you a second blank. We need a second one of these. Remember, we don't actually know this yet. I just was showing you what we need, but we don't know that A is congruent to C yet. Okay. However, for the same reason, ABD is congruent. ABD is congruent to CDB. Also by alternate interior angles theorem. Which means to prove that the triangles are congruent by angle side angle, we're only missing a side, which we have reflexive property, which means DB is going to be congruent to, not an angle, sorry guys, DB is going to be congruent to, let's think about if we have to reverse it, DB, B to B, we are going to have to reverse it, B to D, by the reflexive property. Now let's think about the triangles. I'm just going to grab one of these angles. So triangle ADB is congruent to triangle CBD, which means angle A is congruent to angle C, right here and here, because they are corresponding parts of congruent triangles, or you could put CPCFC. Either one is okay. So we have proved that the opposite angles are congruent. Now we've only proved one set. However, to prove B and D are congruent, you would do the exact same thing. We would just draw a different line and prove it all over again, and we're not going to do that. All right, now I need you to rip out page 425. Go ahead and tear out page 425. You're cutting out 8 and 9. Okay. We're going to glue 8 and 9 to the top of 75. Okay, and we're going to solve these. Okay, so PQRS is a parallelogram. Find each measure. Before we do that, let's go ahead and label what we know since it's a parallelogram. We know that the opposite sides are congruent. We know opposite angles are congruent, but we don't have any angles here, so we're going to skip over that part. We know that the diagonals bisect each other. So this and this are congruent, and this and this are congruent. That should help us answer these questions. So number 8 says find QR right here. So in order to find QR, I'm going to have to solve for Z. So since opposite sides are congruent, I can set 2x plus, not x, Z, right? Yeah, plus 4 is equal to 3Z minus 4. Solve for Z, plug it back in for QR. If you want to pause the video and try that on your own to make sure you get it, then you do that. Okay, I'm going to move over to Z. So I'm going to have 4 equals Z, because I subtract, minus 4. Then I'm going to move over that 4 and have 8 equals Z. Now I need to plug it back in to QR. So QR equals 3 times 8 minus 4. 3 times 8 is 24. Minus 4 is 20. So QR is 20. Pause the video and try to find PR real quick. Okay, PR is this entire diagonal. Before we find this entire diagonal, I'm going to need to find the value of x. So PT is congruent to RT, so x plus 9 is equal to 4x minus 6. Move over this x, so 9 equals 3x minus 6. Add 6, 15 equals 3x. Divide by 3, x equals 5, or 5 equals x. Then I'm going to plug it back in. There are a couple things I can do to find PR. PR is either x plus 9 plus 4x minus 6. Plug in x for both places. Or PR is x plus 9 doubled, by the way. So I'll do both ways and show you what I mean. PR is actually equal to x plus 9 plus 4x minus 6. And I can plug in an x. 5 plus 9 plus 4 times 5 minus 6. We got the order of operations, so 21st. 5 plus 9 is 14, plus 20 is 34, minus 6 is 28. Or, so you do not have to do this one. I'm just doing this one to show you that there's more than one way to do it. Or you could have done x plus 9, so 5 plus 9, which is 14. And since it's bisected, that means the whole thing is double, so it's 28. Either way works. You only obviously have to have one. I just want to show you that both ways work. Okay. All right, today you're doing some proofs and more problems like these for your homework. So go ahead and get started on that. And I'll see you for the next video.